we'll go and get started. Um, Most people have checked in. If you haven't, please do that in on campus. Um, Today, I wanted to go over any quick questions on the first half of the worksheet, but it didn't seem like there were many. So we're going to skip over that. I'm assuming that means that we all got it pretty easily. All right. It's not too terrible. We're just plugging stuff into this equation. Okay. I want to quickly recap what we did last class, which is pretty much what you see on your screen. All right, so the coefficients of a binomial expansion, binomial coefficients, we can find them using this theorem. And basically, it boils down to this equation. Okay, but we also went over a couple of different things. Um, we went over how many terms are in this expansion, right? So if we have the nth expansion, there are a total of n plus 1 terms. And I'm going to kind of call attention one small thing. This first term, this x to the nth term, this is really x to the nth times y to the 0. Then this is y to the first, second, third, all the way up to the nth. Okay, so if that makes it a little bit clearer how many terms there actually are, that often helps me. I like to put that y in there just as a placeholder. And we also went over the different kind of patterns, right? So it starts at the nth term, the nth exponent, and then x, the exponent of x will always decrease. The exponent of y will always increase. And then we also went over kind of the known coefficients, or the more obvious coefficients. And we went over that in terms of this Pascal's triangle. Okay, and we'll be using this just a little bit more here in the next couple minutes. But these are the exponents of the terms, which really boil down to all of these numbers are actually derived from this. Right, so if we rewrite this triangle, say we wanted this term, right? So if this is the 0 term, this is the first term, this is the second term. So we're trying to find the third term within this expansion. All right, what we would do is we would do and actually this ends up being our fourth term. So we would do let's see, this is our fifth expansion. So 5 choose 3. So then this ends up being 5 factorial over 2 factorial times 3 factorial. Which is 120 divided by 12, which is equal to 10. Okay, so we'll be doing this kind of stuff today. We'll be trying to find coefficients of certain terms within certain expansions, and that's what your homework is over. Your homework is a very, very basic. In hindsight, I wish I would have made it just a little bit harder, but this will do for now. Okay. So again, really what this will boil down to is this equation right here. All right, and then besides that, we did a couple of examples. Again, if you were able to do the homework all right, this stuff should be pretty obvious, right? So 8 choose 2, that's 8 factorial over 8 minus 2 factorial times 2 factorial. Okay, again, nothing new here. And what I want to get into today is this. So the first thing we're going to have to be able to do is to expand these binomials. All right. And I have a couple things written here. I have this Pascal's triangle, and I also have this equation. This equation really isn't super important for these lower ones, but it becomes much, much more important a little bit later on. So I'm going to kind of make this a little bit smaller and put it out of the way. If we want to expand 2x minus 3 to the fourth, that is the fourth expansion of 2x minus 3. Okay, so when we're dealing with these low expansions, it's best to just kind of draw the Pascal's triangle and go to where we see the 4 in the first term spot. Okay, so we're dealing with this expansion. And then we kind of match that pattern that we did up above. Okay, so 2x minus 4, or 2x minus 3 to the fourth will end up looking like, I'll do this in green. No, I'll do it in red. So 2x to the fourth, right, that's the first term, plus 2x plus 4 times 2x cubed, right, because of this 4. And then we get negative 3 to the first. And then our next term, we'll start with a 6. And then our 2x will be taken to the second power. And then our negative 3 will be to the second power as well. And then our next term will be another 4. 2x to the first. And then negative 3 to the third. Then we'll have 1, 2x to the 0, which is just 1, and then negative 3 to the fourth. Okay, so that is like the general, that's the expanded version of that form, and we can simplify it just a little bit. But I'll pause there for a second. Are there any questions over how I got that? Because this can be a little bit confusing up front. Okay, so in this case, our first position, this is the 2x. That is normally the x in the general case that we looked up above. Okay, so this 2x will start with a power of 4, and then that power will decrease as we move to the right. This second position will start with a power of 0, and it will increase as we move to the right. Right, so it goes -3 to the 0, -3 to the first, -3 to the second, -3 to the third, and -3 to the fourth. And then same with 2x. 2x goes from the fourth to the third, to the second, to the first, and then to the 0. Okay. And then, on top of that, there are all these coefficients. So the first 4, 6, 4, and 1, which we got from this expansion in Pascal's triangle. Okay, so if we simplify this just a little bit, 2 to the fourth is 16. So we get 16x to the fourth. 2 to the third, that's 8. 8 times 4 is 32. And then we want to multiply that by -3. So we get -96x cubed. 2 squared, that's 4. 4 times 6 is 24, times the -3 squared. It's 216. 4 times 2 is 8. 8 times -3 cubed is -216. And then -3 to the fourth is 81. And before we even get there, we can check each of these terms, right? The sum of the exponents should always be 4. And then the coefficient should follow this pattern. Okay, so again, I want to pause there for a second. Are there any questions over that? Now, in order to get you to think a little bit more down the road, each of these coefficients, so this 1, this 4, this 6, this other 4, and this other 1, each of these can be rewritten as a combination, right? So this would be 4 choose 0, this would be 4 choose 1, this is 4 choose 2, 4 choose 3, and then 4 choose 4. So when you get up to higher and higher expansions, so say instead of the 4th power, it's like the 30th power, right? Doing this Pascal's triangle gets really tedious after like 5 or 6. Okay, so instead of using that to find our coefficients, we would use 4 choose 2 or 4 choose 3. Okay, so let's go over another example. Again, this is just a simple one. We just want to expand it. Okay, and this is going to be the 4th expansion. So we're going to be using that same line. All right, so it's going to start off as x to the 4th. and then it'll be plus 4 x to the third times negative 2y plus 6 x to the second times negative 2y to the second plus 4x times negative 2y cubed plus negative 2y to the fourth. Again, powers of x, powers of this first term, they're going to be decreasing, so it goes from 4 to 3 to 2 all the way to 0. Coefficients follow the fourth expansion and the Pascal's triangle, and then powers of our second term go from 0 all the way to 4. So again, are there questions about that? Because that, again, this can be confusing. So we end up getting, if you just simplify that, x to the fourth minus 8x cubed y plus 24x squared y squared minus 32x y cubed plus 16y to the fourth. That last bit shouldn't be very difficult. Again, that's just simplifying some math terms. All right. And then we start to get to harder stuff. Okay, so now we're being asked to find just the sixth term of the eighth expansion of a plus 2b. Okay, so we could write out Pascal's triangle all the way to the eighth term, but then that takes a little while. So if you're like really comfortable with that and you know like the sixth and seventh terms like by heart, then by all means go for it. But there's a much easier way to do it once we get into higher expansions. Now, something to keep in mind, because we have the eighth expansion, there are really 9 terms, right? There will be x to the 0, x1, x2, x3, all the way up to x to the 8th. And that should be reverse order. So it really starts at 8. And we are looking for the 6th term. So even though this is really what I would consider the 0 term, we're looking for the x cubed of the terms. Okay, so again, I want to stop there real quick. Does that make sense? So then we can just follow our pattern, right? So in our expansion, we'll have a to the 8th, a to the 7th b, a to the 6th b squared. And really, if we know that each of these exponents, like the pairs of them, will add up to 8, we can go straight to a cubed b to the 5th. All right, so that's going to be our variable term. And even we can go even a step further than that. Because it's not just b, it's actually 2b. This will be 2b to the 5th. So if we simplify that a little bit, we get a cubed 2 to the 5th is 32. So our variable term here then is 32a cubed b to the 5th. So I'm going to take that, put it right there. And then we need our coefficient. All right, so again, we're finding the 6th term. So our coefficient will be 8, choose 6. Sorry, not 8, choose 6. 1, 2. This should be 8, choose 5. Yeah, I guess this will be the first term, the second, the third, the fourth, the 5th. No, I guess it does count as 0. Well, let me check that real quick. Yeah, so it should be 8, choose 5. And the way I normally look at it, and it's been a minute since I've really done this, I look at the powers of y. And that'll tell you what to get. Okay, so if we then plug that in, 8, choose 5, ends up being 8 factorial over 3 factorial, 5 factorial. So overall then we get 56 times 32a cubed b to the 5th which is 1792 a cubed b to the fifth. Okay, so I want to take a second. If you have your TI-84 or TI-83, have it out, and I can kind of walk you through how to get this really easily without having to do all of this by hand. And I won't bring up my TI-84 or TI-83 because I don't have that on this computer I'm working on. But there's a really easy way to do it. How did you decide which one to use for the variable term? So I'm guessing you mean a cubed b to the fifth. So we want the sixth term. Okay, so this is where it gets confusing. Sixth refers to when the first variable to the eighth power, that's the first term, right? So this is the first term, even though when we talk about it later, it's the zero term. So for the variables, this is the first term. This is the second, third, fourth, fifth, and then this is the sixth. So when we follow that exponent pattern, we'll get x cubed y to the fifth. All right, so on your calculators, which I hope you have out, you want to go to Math, scroll to the right to Probability, and then you should have a menu with RAND, NPR, NCR, exclamation point, which is factorial, and a couple more options. So if you go down to NCR, hit enter on it, you should get something that looks like this, so long as your calculator is newer and or up to date. And then within those boxes, you just type in those numbers and you get 56. If your calculator isn't up to date, you would type in 8 first and then go to Math, scroll right to Probability, go down to NCR, and then type in your number, and it'll do the same thing. Okay, so if you type in your number first, and then scroll to Probability, go to NCR, hit enter, that number that you choose will be on the left. And then you type in the right number, and you'll have it. Mine won't work for that. It gives me answer NCR. Yeah, you have to type in 8 first and then do it. So your calculator is probably just a little bit older or a little bit more out of date. Okay. So I want to stop for 10 seconds here. Are there questions about anything you see up on your screen? Then it should work like I said that. Like it should work like this, but whatever. If you just type in your number first, it'll work the same way. Okay, I want to do one more example. And again, this works kind of our way up into slightly harder. Why do you multiply your answer to the NCR by the variable term? You're talking about this right here. Because your variable term already has a number in it. Because our second replacement, like our y value, if you want to call it that, is 2b. So that's 2b to the fifth. And when you take 2b to the fifth, it's 2 to the fifth, b to the fifth. Right? 2 to the fifth is 32. And then our 8 choose 5 is 56. So then 56 times 32 is 1792. So it's not just b, it's 2b. Okay. All right, next example. Find the coefficient of the term a6, b5, and the expansion 3a minus 2b to the 11th. Right? So we're not just finding the term anymore, we're finding the coefficient of the term. Okay, I still like to kind of write how we get here. All right, so it'll start a to the 11th. Sorry, yeah, a to the 11th. And then a10b. a9b squared. a8b cubed. And so on. Until a to the 6th. I guess there's just one more, so I'll write it. So when we're finding the coefficient here, gotta just look. Yeah, all right. This is 0, this is 1, 2, 3, 4, and 5. So this will be our like coefficient outside of anything else will be 11, choose 5. But there's still going to be other parts of that coefficient because there are these constants within the parentheses. Right? So our like variable term coefficient, if you want to call it that, will be 3a to the 6th and negative 2b, and that should be on the outside. And then negative 2b to the 5th. Then we can simplify that a little bit. So 11, choose 5. Again, go to math, scroll right to probability, go down to NCR, type in 11, choose 5. That's 462. 3 to the 6th. That's times 729. Negative 2 to the 5th. That's negative 32. And then we can multiply these constants together. So 462 times 729 times negative 32. And then that will be our coefficient of our variables. Again, I want to pause there for a second. Are there any questions over anything I just did? Okay. So before you actually go and do your homework is way more basic than what I thought. Consider that like fundamental questions. All right. The examples that we did, like this example right here, that's like I guess a harder question on a test or a harder question within this reference on a test. Okay. Um, this I would expect you to be able to do on a test as just a normal problem. Um, yeah. So the ones you see on your homework are not necessarily ones you would see on a test. Okay. The examples we did 100% though are. Okay. So the more you can practice this process on your homework, it may seem tedious because they're a little bit easier, but the more you practice this process, the better. So that's what I would encourage you to do. Okay, do this same process, even though it's just a little bit less. Okay, and I don't have anything more for you. That's pretty much the class is just figuring out binomial coefficients. All right, so I'll leave this open for the next minute or two, and then if you have questions, I'll start a meeting on Teams, and we can talk there. Okay. Again, it's part that Teams part is really part of the class. Okay, so if you want to start your homework, and if you don't have any questions, then I would suggest working still in Teams. You can mute us all; it doesn't matter. Um, but if anyone else has to have a question and it ends up being pretty similar to yours, you can kind of just listen in. All right, it's not mandatory. I would highly encourage it though. Okay, so I'll leave this open for the next minute or two. Uh, and if there are no questions, then I'll start a meeting on Teams. All right. I'll close this and I will see people on Teams here in like 2 minutes.